Hey guys, in this video we will see the expression for sensitivity and we will derive it. So we know that the value of our closed loop transfer function or CLTF equals GS by 1 plus GS HS. So we will determine the sensitivity of the system with respect to G and with respect to H. In first case, we will see the sensitivity of the system with respect to G. Then we will derive it with respect of H. So at first, I am just writing the formula. Sensitivity of system with respect to G equals del T by T divided by del G by G equals change in T divided by change in G dt by dg into g by t. So its value will be 1 by 1 plus gh. And similarly, with respect to h, its value will be minus gh by 1 plus gh. Now we are going to derive it. So for sensitivity of t for g, we will write it as change in t divided by change in g equals dt by dg into g by t. So what is t? We know that t is our closed loop transfer function or CLTF. So its value is t equals to g by 1 plus gh del g, and in place of t we will write g by 1 plus gh into g by t. Then we will differentiate this thing denominator into differentiation of numerator minus numerator into differentiation of denominator divided by square of denominator into g by t. Then 1 plus gh minus gh by 1 plus gh whole square into g by t equals minus gh and plus gh will be cancelled out and it will be 1 plus gh whole square. Then g, and in place of t we will write this thing g by 1 plus gh. Then simplify the things, 1 plus gh whole square into g into 1 plus gh divided by g. So gg will cancel out and 1 plus gh will cancel out with the square. So the answer will be 1 plus gh, the sensitivity of the system with respect to g. So here is our desired answer. Now we will solve it with respect to h or feedback path. Okay, so we know the formula is the change in system divided by change in feedback path. Then it will be dt by dh into h upon t. So the value of t equals g by 1 plus gh. You know the value of closed loop transfer function is g by 1 plus gs. I just write it and h by t. Then just do the normal differentiation. Okay, denominator into differentiation of denominator minus numerator into differentiation of denominator divided by square of denominator. Then you can see this whole thing will be 0 and we have minus g square in the numerator, and in denominator we have 1 plus gh whole square into h into the value of t is g by 1 plus gh. This one is the value of CLTF. So after simplifying all the things, we'll get minus g square divided by 1 plus gh whole square into h into 1 plus gh divided by g. G will cancel out by g square and 1 plus gh is cancelled out with the square, so we'll get minus gh divided by 1 plus gh. So this one is the formula for sensitivity for the feedback path system. Now we will see the sensitivity of an open system. So just draw the diagram of open system. So in case of open system, the transfer function is c by r equals g by 1 equals to g. So the sensitivity of system for the g will be dt by t into dg by g equals dt by dg into g by t. So for open system, the value of t will be g, so we just change the t with g, so it will be 1 and it will be 1 into 1 equals to 1. So the sensitivity for open system will be 1.